Hello everyone. Today we're going to work with the Environmental Vulnerability Index, applying an ArcMap to analyze the quality of the vegetation in some landscapes. The Environmental Quality Index of the vegetation try to reflect the sensitivity of the landscape to the biodiversity loss and habitat fragmentation. And he analyzes the patterns of the vegetation fragments, correlating three main analyses: the area of these fragments, the shape of them, and the distance between the fragments. And to do this analysis, we need information about land use and land cover for any area of the world. Here, as an example, I'm going to use São Carlos City in Brazil. And here we have all the land use and land cover fragments from the city, but this specific index only works with the vegetation classes. Then, first of all, we need to extract all the fragments of the vegetation in a unique shapefile. Okay. Here. And to do this, we have two possibilities. We can select by hand with this, with the mouse, or we can here in select by attributes and found the vegetation here and apply. Okay. Then we have all the fragments, the vegetation fragments here select. Then we can here, data, export data. Then we select the folder that we want to save. Yes. Now we have only the vegetation fragments for our study area. The land use land cover we can remove. Okay. I work here with a vector, but if you have a raster, the procedures are the same. We need to select only the vegetation classes and extract. Okay? And for this analysis, we are going to apply the same methodology as my co-workers and I used in this paper, publishing the ecological indicators. And on this paper, we analyze a set of environmental index to understand the impacts of land use and land cover change around time in a specific area in Brazil, the Tietê-Jacaré watershed in São Paulo state. Then we apply the environmental quality index, the water resources quality index, and the vulnerability index. Then we try to understand all these transitions and impacts of the pattern of the land use and land cover around the time for this region. Okay, And also in the methodology, we explain all this, which means all this kind of index and the collaboration of this index for our knowledge. Okay. Now, to start it, to analyze our index, we came to the equation here again. Then we need the area of these fragments, the shape, and the distance between these fragments. Then the first of all, the area. We can open our attribute table. I already have the column area here, but to create, we can here, add field, put a name here, float. This float option is to put numbers with 0.1, 0.2, 0.3, if not integrate numbers, it's important. And we came here and I will erase one. Okay. Remember to check your coordinated system. I may use here Sirius 2000, it's a Brazilian datum, and UTM zone 23 South. Okay, but remember each area around the world will have a different coordinated system. Okay. First, I'm going to here, calculate the geometry, area, the unit. Normally, I like to use the squares or the square kilometers or hectares. Okay. The importance is that we use the same kind of unit in all the analysis. For example, if I'm work with kilometers, I need to work with kilometers with all the parameters, because in this way we can compare and do the math inside the software. Okay, it's not okay. We cannot use hectares in one and square kilometers in other. Okay, this will difficult our math. Here. Now we have the area of the fragments. Okay. The second one, perimeter. We do the same here. The perimeter is the shape. Okay. Here. We analyze here. Okay. If I put the kilometer squares in the area, now in the perimeter, I'm going to work with kilometers. Okay. That's it. Then we have the two first analysis. We already have the area, the shape, and the last one is the distance. But to work with the distance, we need to convert our vector to raster. Okay. Here. Then we found these two boxes, polygon to raster. Then we need to. We don't select anything here. Okay. Save. Then we have our vector as a raster. Okay. Then to calculate the distance, we can also found here in toolbox, special analysis tools, distance. Then you're gonna work with this one, the corridor. This one will analyze the distance between the fragments. Okay? Select here. Compare. This one. Now we have the analysis of the distance. Okay? I'm just erase the first one because I was doing a text. Then we have the distance. To compare and continue the equation, we need to transform our vector with the area, a vector with a raster with the area, and a raster with the perimeter. Okay, then we are going to do this transformation. Polygon to raster again. Oops. Polygon to raster. Now here we need to change the field. Take a look. The first of all, it's the area. Then we're going to select area here. Now it's here. Again, with the perimeter. Save here. Okay. Maybe again. Then we have the perimeter. Now we have the area, the distance, and the perimeter. But we have a problem. Take a look. The numbers are different between them. Then we don't have our parameters in the same scale. Then we need to patronize this to have the possibility to compare and do the equation here. To do this, to put them in the same standardization, we are going to use the fuzzy application. Then this fuzzy application, it's a math operation that put all the parameters between 0 and 1. Then the high valuation we're going to put in 1, and the low variation put in 0. And the numbers between all this classification will be standardized between 0 and 1. And we're going to do in the 3 parameters here. We are going to work with the fuzzy over membership. First, we select our 3 parameters, the area, the distance, and the perimeter. Select the membership. We're going to do the first with the area. And take a look. This is the maximum number we have in our area here. Take a look. And this we can change for 0. Okay? We only change the minimum for 0. Okay? The maximum will have the same as our layer here. We save area fuzzy. the classification. Okay? If you don't change anything here, sometimes the low number has some errors. Okay, it's a problem with the software. Then we always need to change only the minimum number. Okay, put 0 here. The maximum we don't change because it's the reference of each layer. Okay, change the area we already done. Then we can close here, and the next one is the distance. Select the distance here, linear. It's already 0 here. Fuzzy. 1. Okay, close the distance. And now we have the values of the distance here. Okay. And the last one is the perimeter. And select here, linear, put 0. Wait. The same. Okay. And now we have our 3 parameters in the same scale of analysis. Then we can compare and do any kind of math inside these fragments. Okay? And to do this equation in the software, we're gonna use the raster calculator. Oops. We do the same as the equation here, the sum of the 3 parameters split by 3. Okay. And we save. Then we have the fragments with the quality. We can also do the same standardization with the fuzzy here to have number between 0 and 1. Okay, this in our study in this paper it was necessary because we work with a lot of different indices. Then the idea in this paper it was compare this classification. Then we also did the fuzzy logic in the final result of each index. Okay, then the same. Linear. Only change the number here. The name is too large here. Then we have the numbers between 0 and 1. Here, this is the result. Okay. Then we can classify between equal intervals. 4 as you want. Then we have the quality. Values close to 0, it's a low quality of the fragmentation of the environmental quality. Then normally we have small fragments with a high distance and a low period. Then we have a low quality of the vegetation. And fragments with has a high perimeter and has a high area and have a connection with other fragments tend to have a high quality in the classification. Okay, and that's it. Thank you and have a good work.